Slide 1. Beyond Search, Using AI to Uncover Hidden Patterns in Digital Archives. Hello, my name is Kevin Hegg. As Jesse said, I am the head of digital projects in the JMU libraries. Today, we'll explore how OpenAI's custom GPTs can enhance our ability to explore and analyze digital archives. Custom GPTs help us find patterns and connections that traditional search methods might overlook. This presentation highlights 3 collections comprised of over 3 million words of transcripts and newspaper content, each providing valuable insights into history and culture. Slide 2. Introduction. These 3 collections, Voices from the Blue Ridge Mountains, the WPA Federal Theater Project, and Augusta Country Newspapers, serve as our case studies. Using custom GPTs, we move beyond basic keyword searches to uncover otherwise hidden patterns, themes, and connections. This approach is inspired by Franco Moretti's concept of distant reading, which focuses on analyzing large bodies of text computationally. I'll return to this concept in a moment, as it's key to informing this approach to interrogating digital archives using AI. The links on the page will take you to each of the custom GPTs. You will need a free or premium ChatGPT account to access these GPTs. Slide 3. The digital collections behind the GPTs. Each of these collections offers a unique historical and cultural perspective. The SNP Oral Histories collection contains interviews with residents displaced by the creation of the Shenandoah National Park in the 1930s. It highlights Appalachian culture and life on the Blue Ridge Mountains before the creation of the SNP. The WPA Federal Theater Project captures voices from the 1930s community theater movement. It showcases cultural and social insights of that era. The Augusta Country Newspapers offers local news from the 1990s-2000s. It presents community life and issues in rural Virginia. Each collection provides a strong textual foundation for a custom GPT, allowing ChatGPT to analyze content at scale. I collaborated with JMU and George Mason University to ingest these resources for the GPT models. Slide 4. Franco Moretti's concept of distant reading. Franco Moretti introduced distant reading as a way to analyze literature at scale. Rather than closely examining individual texts, distant reading offers a bird's-eye view of vast literary collections, allowing researchers to identify broad patterns, themes, and shifts across entire genres or periods. As the volume of published works grew exponentially, particularly in the 19th and 20th centuries, it became impractical to analyze each text individually. Distant reading emerged as a response to this explosion in literary output, using statistical and computational methods to uncover general trends within large bodies of text. The rapid growth of digitized and born digital materials creates a similar challenge in digital archives. Computational approaches, like distant reading, become essential to make sense of the massive data in our digital archives. Custom GPTs are well suited to this task, as they can quickly process and analyze vast amounts of text, revealing hidden structures, historical trends, and cultural patterns within archival collections that would otherwise be hard to detect through close reading alone. Slide 5. Beyond Search, an SNP Oral History Lesson Plan. This slide holds a link, the response link, to a shared ChatGPT conversation. Shared conversations do not require a login. With the SNP GPT, we support educational initiatives by offering pre-configured prompts that engage students in exploring key themes, like displacement and traditional practices. For example, teachers can prompt the GPT to create a lesson plan on the theme of displacement. This lesson plan, suitable for high school students, uses oral history artifacts to foster a deeper understanding of historical experiences. It's designed to guide students toward connecting with real human experiences documented in the oral histories. Slide 6. Beyond Search, FPT as Community-Based Theater. For the Federal Theater Project, our custom GPT can help students develop research topics, outlines, and thesis statements. Preset conversation starters introduce users to significant historical themes and provide primary sources for analysis. For example, a history student might prompt this GPT for essay ideas, including citations and an outline. This approach enables students to engage deeply with primary sources while reinforcing critical thinking skills. We encourage students to use the GPT as a starting point for research rather than a substitute for independent analysis. The link here takes you to a conversation with the FPT based on the prompt "How is the Federal Theater Project community-based theater?" Slide 7. Beyond Search, Impact of the Civil War on Augusta County. The Augusta Country GPT allows visitors to explore, for example, extreme weather events, local celebrities, or the perceived impact of the Civil War on the local community. While OCR transcriptions power this GPT, they reflect the quality of scanned newspaper images and the limitations of Adobe Acrobat's OCR algorithm. This GPT is a valuable tool for discovering regional perspectives and events, but users should remain mindful of its limitations. By using prompts that focus on available documents, users can uncover fascinating local insights that were previously hidden. Slide 8. Creator's Guide. Anatomy of a Custom GPT. Creating a custom GPT requires several key elements. The name and description should clearly define the GPT's purpose. Plain language instructions guide the GPT to base its responses on the data and documents in the GPT. The knowledge base is the repository for the documents and data that will inform the GPT's answers. Capabilities and actions are bespoke functions for specific tasks or capabilities. I haven't implemented actions for any of these GPTs. Together, these components shape a targeted, data-driven assistant that offers users direct access to the unique information within each collection. The instructions, especially, are vital to prevent the GPT from straying into excessive editorializing and over-reliance on its general knowledge. Slide 9. WPA-FTP. Metadata for an oral history. This slide shows the metadata for an FTP oral history. I copied the metadata shown here directly from the GPT. It includes descriptive details like interviewee, interviewer, and location. The metadata includes a link to the source interview. The summary is generated on the fly by the GPT. Each entry is structured in JSON format, which the GPT uses as a reference when generating responses. Metadata organization is essential for contextual accuracy, allowing users to retrieve precise details from each interview. In this case, the FTP metadata captures nuanced historical perspectives that would be difficult to uncover without structured, machine-readable data. Slide 10. Augusta Country. Metadata for the October 1994 issue. You may have noticed some naming confusion. The Augusta County newspaper was called the Augusta Country. For this GPT, metadata like title, publisher, and coverage create an organized, searchable archive within the GPT. This structured metadata allows users to retrieve information based on specific dates, locations, or themes, making it easy to find context-rich, accurate answers. Here, the GPT model draws directly from metadata to guide users through local historical records with enhanced precision and reliability. Slide 11. Building a custom GPT. Knowledge. The knowledge section is the core reference point in any custom GPT. This section allows us to upload specific content such as newspapers, spreadsheets, interview transcripts, and metadata. The GPT will use data and documents in this section to generate accurate, context-driven responses. The uploaded files act as a lookup resource rather than altering the GPT's underlying language model. This is different from training or fine-tuning, where the model's core capabilities are adjusted. Here, the GPT remains the same but draws on the provided content to inform its responses. There are some limitations. File formats. Accepts a wide variety of formats, including PDFs, text, CSVs, images, and JSON files. It won't accept AV files, code files, zipped files, encrypted files, executables, etc. File size limit. Each file can be up to 20 megabytes. Total file limit. We can include up to 100 files, giving us a maximum of 2 GB of file storage, which can hold over 300 million words of plain text data. Slide 12. Building a custom GPT. Gathering knowledge with Python. To gather and structure data for our GPTs, I used Python scripts to scrape metadata, extract text, and build JSON files. Each GPT object contains metadata and transcriptions, organized within the knowledge section. My scripts were invaluable in helping me gather and structure content and metadata. JSON is GPT's preferred format for consistency. I used ChatGPT to automate much of the Python coding, which streamlined the process and made it more efficient to handle bulk data preparation. After my initial experiments, it took about 4 hours to create each GPT presented here and then several more hours for testing and fine-tuning. The JSON object on the right is from the WPA Federal Theater Program GPT. It contains a link to the oral history itself, metadata, and the content of the transcribed oral history. Slide 13. Building a custom GPT. The art of instruction. Clear instructions are essential to keep the GPT on topic. For example, the SNP GPT instructions specify that responses should rely on the collections, documents, and data, and should avoid over-reliance on external general knowledge. The model is also instructed to avoid imaginative responses. These boundaries help maintain accuracy and ensure responses reflect the data available within the GPT. Giving the GPT direct, plain English instructions makes it easy to ensure that responses align with our research goals without technical complexities. Slide 14. Lessons learned in custom GPT development. Here are several key lessons or challenges that I encountered through building and using these GPTs. Hallucination and editorializing. Without strict guidance, GPTs may invent information not in the knowledge base, potentially leading to misinformation. Over-reliance on general knowledge. GPTs sometimes default to general information rather than focusing on the documents and data in the GPT. This can dilute the response quality and make it harder to understand our collections. Usage policy risks. Certain questions may prompt responses that breach OpenAI's usage policies. Careful monitoring and ongoing adjustments help mitigate these issues. Links are unreliable and access is restricted. I included links in each GPT to the source materials, which users can then use to evaluate the validity of GPT responses. Often, the links are unclickable or wrong or missing altogether. This is something that I hope is fixed in future versions of custom GPTs. I also hope OpenAI makes its custom GPTs accessible without a login. These lessons underscore the importance of vigilant oversight and clear instructions when developing custom GPTs. Slide 15. Beyond Search, AI-driven exploration of digital archives. In conclusion, custom GPTs allow us to go beyond simple search, uncovering deeper connections and insights within a digital archive. Inspired by Moretti's concept of distant reading, we can employ GPTs to analyze and understand large text collections. Python and AI coding assistants streamline the construction of custom GPTs. I am not convinced that OpenAI's custom GPT technology is mature enough at present to move into production and share widely with our constituents. However, LLMs are evolving quickly and now is a good time for experimentation and conversation. Thank you for letting me share my experiments with custom GPTs.